Okay, so in this lesson, we're going to be talking about graphing quadratic functions, but it'll just be the basic information. In the next lesson, we'll um, dive deeper into graphing quadratic functions that are written in standard form. Um, but here we're just getting a basic understanding of quadratic functions, their shape, and information about it. So the first thing we need to be able to do is define what a quadratic function is. So a quadratic function is any function of the form, and it looks like this: f of x equals ax squared plus bx plus c, where a, b, and c are any real number. Now remember, a cannot equal 0, because if a was 0, here's what would happen. If a is 0, this term right here would be 0. So 0 times x squared is 0, and you would be left with this, bx plus c. But that's a linear function. So in order for it to be quadratic, b can be 0, c can be 0, but a cannot be 0, because if a is 0, so you'll never see a being 0. So there's always going to be an x squared term. There'll be times when you won't see a x term, and there'll be times when you won't see a constant, but you'll always have an x squared, because it's the only way it can be quadratic. So again, if a is 0, this is no longer quadratic, this is linear. So it'll be a linear function. Okay, so a quadratic function is a polynomial whose greatest exponent is 2. So that's what we said. So if this is 0, then it would no longer be quadratic, it would be linear. B can be 0, you would still have the greatest exponent being 2. C could be 0, this constant can be 0, you would still have the highest exponent being 2. So that's what makes it quadratic, is that highest exponent. So it has to be a 2. All right, now the graph of a quadratic function is a parabola. So you may remember this from last semester, where you graphed quadratic functions and absolute value functions, but those were basic functions. So here what we're going to do is just kind of review last semester, the kind of graphs you had to do last semester. And then the next lesson we'll look more into the college algebra part of graphing quadratic functions. But let's kind of review a couple of things. So if this is my xy plane right here, so this is the x-axis and this is the y-axis, and let's suppose I just draw a quadratic function, a parabola. So let's say the parabola looks like this. Okay, now I'm not drawing it very well, but that's what it looks like. And so this point right here, that lowest point, see there's a low point, that minimum point, this minimum point, now remember, a min from a previous lesson, remember how it's going from, y coordinates are going from decreasing, and then all of a sudden it's increasing? Okay, so they're still going to ask you about these information about functions, but the new part, well, not the new part because you had this last semester, that this minimum point, that's the vertex. So from last semester you knew this was called the vertex. So this is the vertex. All right. Now, notice that all parabolas. Now, remember in a previous lesson when you talked about even, odd, and neither, that when we drew an even, a quadratic function that was symmetric about the y-axis. See how this quadratic function, this parabola, is symmetric about the y-axis? This would be an even function. Okay, remember that? That's an even function, because if you take this part, fold it about the y-axis, you'll get this part back. So if this is the point, I'm just saying, if this is the point, let's say 2, 4, then this would be the point negative 2, 4. So remember, in an even function, the y-coordinates are the same, the x-coordinates are opposites of each other. So this even function had symmetry. Remember we talked about symmetry. So an even function would be symmetric about the y-axis. Symmetric about the y-axis. All right, so that's a review from a previous lesson. So this parabola, which is an even function. Remember, an even function is symmetric about the y-axis. So this parabola has symmetry. The symmetry is the y-axis. Okay. Now the question is, do you see that this is not an even function? It's not an even function because it's not symmetric about the y-axis. It's not an even function because it's not symmetric about the y-axis. But it has symmetry. All quadratic functions have symmetry. So all quadratic functions have symmetry, and it's very easy to determine the symmetry. So if I take a ruler and kind of, and again, I didn't draw this very well, but if I place the ruler over the vertex like this, and I draw a dotted line, kind of like this, okay, draw a dotted line. All right, so after a while, you got to make sure it's a dotted line, and there are arrows here. See how this part of the graph, if I reflected about this dotted line right here, I get this part back. All right, so that line right here, that line, whatever that line is, but it's always going to go through the vertex. It's always going to go through the vertex. That line is called the axis of symmetry. The axis of symmetry. All right. So for this even function here, the axis of symmetry would be the y-axis. So for this even function, so for, let me go ahead and write this. For this right here, I'm going to go ahead and do this for now. So I just move the parabola up, but this is still, the y-axis would be the axis of symmetry. Because this even function, remember this is an even function. All even functions are symmetric about the y-axis. And so the y-axis is the axis of symmetry. So the axis of symmetry is the y-axis. Okay? Oops. So the axis of symmetry is the y-axis for an even function. Over here, though, that's not the y-axis. The y-axis is here, but it still has this parabola still has symmetry. It is symmetric about this dotted line, and the dotted line is called the axis of symmetry. Okay? All right, so we're going to see what that line is. See how we knew that this line, the axis of symmetry, was the y-axis? Here you might be asking, well, what is that line? Well, it's a vertical line, and you know how to name a vertical line. So we're going to look at this in the, actually we're going to do this in the next few problems when we get to it. All right, so but that's the axis of symmetry. Okay? All right, now, so my parabola can go up like that. Now, this right here, remember we denote the quadratic function using this. So I'm going to go ahead and say this right here. I'm writing this over. So f of x equals ax squared plus bx plus c. So what I want you to notice now is this, and you're going to see in a couple examples in a little while. See how this parabola is going up? It's going up. Well, if the parabola is going up, that means that the coefficient of x squared a, that means that a is greater than 0. So that means that a is positive. So if a is positive, that means that the parabola opens up. Parabola opens up. All right, so you're going to see that. All right, so even functions, and so all this is review. This part here is review from a previous lesson. Even functions is symmetric about the y-axis, so the axis of symmetry is the y-axis. This is not an even function because it's not symmetric about the y-axis, but it still has symmetry, and the symmetry is called the axis of symmetry, and we're going to find that soon. Since the parabola is going up, that means that the coefficient of x squared, a, is positive. So if a is positive, the parabola will open up. All right, now let's compare that with one that opens down. So let's say we had this. So here's my x-axis, here's my y-axis, and let's suppose that the parabola does this. All right, so it opens down, and remember this is y equals ax squared plus bx plus c, or f of x. And again, this is, remember this is called the maximum point. So when you go from increasing to decreasing, this is called a local min, but it also happens to be the maximum, the absolute maximum. So that's the maximum point. All right, so you learned that last semester. That's also called the vertex. Okay, so the vertex here is a maximum point. All these other points are below it. This is the maximum. That's the maximum point right here. Now the axis of symmetry, remember the axis of symmetry, all all parabolas, all quadratic functions have an axis of symmetry. And the axis of symmetry always goes through the vertex. So you draw a vertical line through the vertex. Make sure it is dotted. So we want to use a dotted line to denote the axis of symmetry with a line with arrows. All right, so remember this is called the axis of symmetry. It is very easy. Once you find the vertex, it's easier to tell me what the axis of symmetry is. But you got to find the vertex. You must know the vertex. You can get from the vertex, I should say. You can get from the vertex. So there are formulas you're going to learn in the next few lessons about how to find the axis of symmetry if it's in this form. All right, very easy to find the axis of symmetry and the vertex. Okay. All right. So again, if A is see how this parabola is opening down, it goes down. The arrows are pointing down. Then that means the coefficient of x squared A is less than 0, meaning that A is negative. So if A is negative, the parabola opens down. All right, so if A is negative, the parabola opens down. All right. Okay, now let's look at some examples. I think that's where I want to go next. All right, so let's look at some examples. Oh, so you may say, well, you have A is less than 0, and you have A is greater than 0. Well, what about if A is equal to 0? Well, remember, it can be. A can never be 0, because if A is 0, it's no longer quadratic. We're only talking about quadratic. Quadratic functions have shapes that are parabolas. If A is 0, it's linear. A linear function is a line. Okay, so just remember, A can never be 0. You're always going to have a number for A. There will always be an x squared term. Okay, now let's look at some examples. Let's see, I want to go next with this. Okay, I did not mean to do this part. Okay, all right, so let's look at this. So remember last semester you graphed f of x equal x squared? All right, and you use a t-table. We use a t-table to graph this. And so I'm going to go ahead and get some grid paper. All right, so if x is 0, we get y equal 0 squared. Remember, all I'm doing is just plugging back into x. Remember, f of x means the same thing as y. So y equals 0 squared, which is 0. I get the origin, and plot the point 0, 0. If x is 1, I get y equals 1 squared, which is 1. So we plot the point 1, 1. If x is 2, I get y equal 2 squared, which is 4. So I get 2, 4, which is here. And I don't have enough room to do 3, because 3 would be 9. Well, y value would be 9. I don't have enough room here. So let's go to the negatives. So remember, it's a parabola. So you can see the general shape on the right. You see this? The general shape on the right? Do the best you can with drawing a parabola. Now, it's not. Don't draw any lines. It's got to be a curve. So do the best you can to do this. All right, now remember, what we talked about, all quadratic functions have symmetry. So visualize, when you do the rest of this, visualize this piece being reflected about, and in this case, it's going to be the axis of symmetry, it's going to be the y-axis, so this is an even function, reflected about the y-axis. Okay, so this point, I want you to notice, this point, when we reflect about the y-axis, becomes this point. See how this is 1 unit from the y-axis? 1 unit, 1 unit. See this? It's got to be important because you're going to be using this in the next few lessons. So you got to see this. So you see how if I reflect this point about the y-axis, count the number of units. 2 units from the axis of symmetry, 2 units from the axis of symmetry. So watch, you're going to get this point, and you're going to get this point. So you're going to be using that idea. You're going to be using that idea in the next few lessons. Okay? Now, let's use a t-table and make sure we get this. So here, x is negative 1. Let's see if we get it. So negative 1. All right, now you got to remember, when using negative numbers, you really need to put that in parentheses because that's being squared. So negative 1 squared means negative 1 times negative 1, which is 1. All right, negative 2, y equals negative 2 squared, which is negative 2 times negative 2, which is 4. So let's see if we get that. So remember, look, Negative 1, 1, that's this. Negative 2, 4, that's this. So remember, use the idea of symmetry in your mind when you graph this. So it's all parabolas have symmetry. Use that fact. You must use the fact that all parabolas have symmetry to help you graph this. Now that's going to be important when we start looking at the quadratic function being written in what's going to be called standard form or vertex form. All right, so that's y equals x squared right here. All right. Now, let's look at this one. So let's call this number 1. Okay, number 2. Suppose in number 2 I had this. F of x, I'm going to just call it y for right now. Y equals x plus 2 squared. Okay? Y equals x plus 2 squared. Let's see what that looks like. So I'm going to use a t-table just like you did last semester. So last semester, this is the kind of stuff that you did. So if x is, let's say, negative 2. Let's do negative 2 for right now. If x is negative 2, I get y equal negative 2 plus 2 squared. And negative 2 plus 2 is 0. 0 squared is 0. So I get negative 2, 0. Okay? So negative 2, 0 is here. If x is, let's say, negative 1. Negative 1. And I chose negative 2 because we're going to notice something in a little while. You may say, well, why do you go to 0, 0? There's a reason I chose negative 2 first. And this was discussed in a previous course last semester. But basically, when you're graphing quadratic functions, you want to find out what's going to make this right here 0 first. That's what you want to do. So, what's going to make this 0 is going to be negative 2. So negative 2 plus 2 is 0. Now, you learned last semester that when you do that, you're actually finding the vertex, or you're finding the x-coordinate of the vertex. So that's going to be the x-coordinate of the vertex. So you're going to notice. See, when I picked negative 2 and then I found out what the y value is, this is going to be the x-coordinate of the vertex, and it's going to be the y-coordinate of the vertex. You're going to see this in a little while. So here's negative 2, 0. The negative 1, and there's a reason why I'm choosing points, and as we go through this, you're going to see this, and that's going to help you in the next lesson. So I'm going to choose negative 1 now. So I'm using integers. Don't use any decimals. Don't use any fractions. Use integers, because that way you can easily get some points very efficiently. I could have chosen negative 1.26 if you wanted to, but why would you do that? Use integers, because integers makes the computation a lot easier. All right? And it's also difficult to estimate where some of those points are if you use decimals or fractions. So use integers. So if x is negative 1, I get y equals negative 1 plus 2. Oops, negative 1 plus 2 squared. Negative 1 plus 2 is 1. 1 squared is 1. So I plot the point negative 1, 1. Now what's happening? You remember we said a while ago that if you want to find the vertex, the x-coordinate of the vertex, or if you want to find the x-coordinate of the vertex, just find out what makes x plus 2 positive. So x plus 2 is 0. So x plus 2 is 0 when x is negative 2. So that's why I chose negative 2. So once you find the vertex, see, this is going to be the vertex right here. Once you find the vertex, pick 2 x-coordinates on this side, 2 x-coordinates on that side. Okay, so I'm going to repeat this. Once you find the vertex, pick 2 x-coordinates on this side and 2 x-coordinates on this side. 2 x values on each side of the vertex. All right? Now, you remember what we said a while ago. We said a while ago that the axis of symmetry goes through the vertex. Remember that? The axis of symmetry goes through the vertex. So here's what I want you to think about. I want you to start thinking about drawing that axis of symmetry. So here's my vertex. Okay? Here's my vertex. You can draw the axis of symmetry. Kind of looks like this. All right? I didn't draw it very well. I was supposed to go through this vertical grid line right here. All right, so that's the axis of symmetry. Now remember what we talked about a while ago? Always make some connections. See how when we got this, we said, well, the y, since this was an even function, the y-axis is the axis of symmetry, and so I just reflected these points about the axis of symmetry. I got the other point. So look, this is 1 unit from the axis of symmetry. I go, 1 unit this way, I get this point. This is 2 units from the axis of symmetry. I reflected about the y-axis. This is 2 units, I get this point. Okay? You can do the same thing here. See how this is 1 unit from the axis of symmetry. I go 1 unit this way, and that's going to be the other point. So I need one more point on this side to help me draw a good graph. So let's pick one more point. Let's pick -1. You can pick 1 if you want to, but the problem is when you pick 1, here's what happens. 1 plus 2 is 3. 3 squared is 9. The problem is you don't have enough units to get to 9. So pick 0. The next one's going to be 0. So when x is 0, I get y equals 0 plus 2 squared, which is 2 squared, which is 4. And notice I get 0, 4. Now watch. When you get 0, 4, use the idea about the axis of symmetry. The axis of symmetry. See, this is the axis of symmetry. 2 units. This point is 2 units from the axis of symmetry. Go 2 units this way. And visualize you reflecting about the axis of symmetry. If I take this point and reflect it about the axis of symmetry, do I get this point here? And the answer is yes. And so, guys, all you got to do now is just draw your parabola. That's all you do. So just do the best you can with drawing the parabola. It could be better than this, but just do the best you can. Make it a curve, though. Don't ever make these segments. All right, and so visualize and notice that it kind of looks like it's symmetric about the axis of symmetry. All right, now before we go on, I wanna start talking about what is the axis of symmetry. How do you define it? Okay. All right. So you remember, and I'm going to go ahead and do this here. You remember when we graphed vertical lines? So the axis of symmetry. First of all, you got to notice that the axis of symmetry are vertical lines. You have to notice that. Hopefully, you see that those are vertical lines. So the vertical lines. Remember, vertical lines have this equation. It's always going to be x equal a number. All right, x equal number. So that's the equation of vertical line. So remember when we graphed x equal -2, let's say, and I use a t-table. And remember what this means is that x always equals -2. That's what that means. That no matter what y is, x always equals -2. That's what this is saying. So no matter what y is, so if y is 0, x is -2. If y is -4, x is -2. If y is 2, x is -2, and so on. That's what that says. So when I graph this, when I apply to those points, -2, 0 is here. -4, I didn't scale it very well, but that's fine, is here. -2, 2 is here. Notice you get a vertical line. So a vertical line has this form, x equal number, and that number is where it crosses the x-axis. See, cross the x-axis -2. So that vertical line is x equal. See, here's visualize it as well. No matter what point you pick on the x-axis, I'm sorry, on the vertical line. No matter what point you pick on the vertical line, what do you notice about the x-coordinate? The x-coordinate always is -2. All right, and so when you name a vertical line, it's going to be a x equal number, and just think about where it crosses the x-axis. It crosses the x-axis -2, and in fact, all of these x-coordinates are -2. So what you're saying that when you write this, you're saying that x always equals -2. That's what you're saying. So when I go back over here now, all right, so remember, vertical lines is always x equal number, and it's wherever it crosses the x-axis. When I go here, that's a vertical line. Can you tell me what the axis of symmetry is? The axis of symmetry. So the axis of symmetry is x equal a number. What is that number here? What do you think that x equal that number? What do you think that number is? Well, remember, it's where it crosses the x-axis. So it crosses the x-axis -2. So that's your axis of symmetry. All right, over here, what was the axis of symmetry? Well, this was an even function, right? That was an even function. So the axis of symmetry is the y-axis, but you got to name it as an equation. You can't just say axis of symmetry y-axis. I mean, if you could mathematically, that's nothing wrong with that, but we want you to name it as an equation. So here's the equation: axis of symmetry is x equal a number, and it's whatever that x-coordinate is of the vertex. So what's this x-coordinate of the vertex? The x-coordinate here is 0. All right, so remember the vertex. Let's talk about the vertex. So the vertex is this low point, the minimum. So the vertex is the minimum here, and it's 0, 0. The axis of symmetry, remember, is x equal this number. So once you find the vertex, you know the axis of symmetry. It's x equals 0. The vertex here is negative 2, 0, right? Negative 2, 0. So the axis of symmetry is x equal negative 2. That's your x coordinate. Okay? All right, and the vertex, remember the vertex we just said, but I'm going to go ahead and write it out. So the vertex here is negative 2, 0. And notice that the parabolas in both cases are going up. And remember this one was y equal x plus 2 squared. And make sure you understand why it's going up. So remember we said in our notes that if the coefficient of x squared is positive, so if a is positive, the parabola opens up. So I want you to notice, see this x squared right here? There's no x term, there's no c term, so they're all zeros. But the x squared is a positive 1. So a is positive 1, so it opens up. Here, if I were to multiply this out, I want you to notice something. X plus 2 squared means x plus 2 times x plus 2. So when you FOIL it, this is x squared. The outer is 2x. The inner is also 2x. And the last is 4. 2 times 2 is 4. And so I get x squared plus 4x plus 4. And so that's y. So I want you to notice what the coefficient of x squared is. The coefficient of x squared is also 1. It's positive. So notice it opens up. And in fact, you didn't have to do all this. You could have just looked at this number right here. That number right here is a 1. It's a positive 1. So the number inside the parentheses is a positive 1. So since it's positive 1, since it's positive, it's going to open up. Okay? All right, let's look at another one. So suppose we had this. Get another sheet of paper. All right, suppose we had... All right, let's suppose we had h of x is number 3. H of x equal x plus 1 squared minus 2. All right. So it's going to, and the reason I'm using these forms right here, see how it looks, is because this is what we did last semester. So we graphed quadratic functions that had this kind of form. And it's quadratic because if you FOIL this out, you're going to get x times x, which is x squared. Okay? So it is quadratic. All right, so let's use a t-table for right now. And here's what I want you to think about. Remember, we talked about, first of all, find the x-coordinate of the vertex and start from there. That's the best way to do this. All right, so remember how to find the x-coordinate of the vertex. You take what's being squared, x plus 1, and you ask yourself, what makes this 0? So what you're doing is saying, x plus 1 equals 0, solve that equation, subtract 1, and you get x equal negative 1. So what you found, this is the x-coordinate of the vertex. That's what you found. And when we graph this, you're going to see that that is true. So negative 1. Okay? Now let's find the y-coordinate vertex. So where we see an x, you plug in negative 1. So we're going to say y equals, remember h of x means the same thing as y. So we say y equals x, which is negative 1, plus 1 squared minus 2. Now remember, negative 1 plus 1 is 0. That's how we found the x-coordinate of the vertex. And 0 squared is still 0, and 0 minus 2 is a negative 2. So basically, I found the vertex. The vertex is, for this right here, this number 3, which is h of x equal x plus 1 squared minus 2, right here. So I found the vertex is negative 1, negative 2. Yep, right here. Okay, so that's a vertex, negative 1, negative 2. And so all I got to do is pick 2 points, 2 x coordinates on the right, and then use the idea of symmetry to find it on the right, on the left. Okay. Now I want you to notice, see the axis of symmetry is going to be this point right here, because that's the vertex. I mean, this line, excuse me, this line. All right. Okay, so give me 2 x coordinates to the right of x equal negative 1. So let's say 0. All right, 0. So notice I'm just going down by 1 unit. So negative 1, 0, the next one will be 1. And the next one will be 2 if I wanted to, but I wouldn't use 2 because 2 plus 1 is 3. 3 squared is 9. 9 minus 2 is 7. And and I still don't have enough room. So just be strategic. Make sure your points lie on the grid that we're using. So if x is 0, I get y equals 0 plus 1. 0 plus 1 squared minus 2. 0 plus 1 is 1. 1 squared minus 2. Well, 1 squared is 1. 1 minus 2 is a negative 1. So I get the point 0, negative 1. Right here. All right, give me one more number for x. So if x is, let's say, 1, I get y equal 1 plus 1 squared minus 2. 1 plus 1 is 2, so 2 squared minus 2. 2 squared is 4. 4 minus 2 is a 2. So I'll put the point 1, 2. So 1, 2 is here. All right, now I'm going to draw my axis of symmetry to help me. I'm going to draw the axis of symmetry to help me. The axis of symmetry goes to the vertex. It goes to the vertex. And as we go through the discussion, I want you to notice something. See this coefficient right here? That coefficient is a positive 1. The number outside is a positive 1. Since it's positive, see how your parabola is opening up? Okay, so just make sure you see that. All right, and so we get something that looks like this. All right, make sure. A lot of students, not a lot of students, but there are some students that will do. No, what's what I'm doing? We'll do this, and then all of a sudden go up like this. It does not. It does not go straight up and down. Okay, it's a curve. Make sure it's a curve. Make sure it's a curve so you don't lose any points. All right, and then now what I would do next is I would just use symmetry. So you see this point right here? That's 1 unit from the axis of symmetry, so go 1 unit this way. Because remember, the parabolas, all quadratic functions are symmetric about the axis of symmetry. So if this is a point and reflected about the axis of symmetry, I get that point here. So think about the distance. This distance, same as that distance. So my question to you now is this: how many units is this point from the axis of symmetry? Well, 1, 2. 2 units. See this distance? I'm kind of tracing over here, that distance. So if I reflect it about the axis of symmetry, I'm going to get this point here. So 2 units this way, 2 units that way. Okay? So 2 units this way, 2 units that way. So there's the other point. And then all you do is just draw your graph, make sure it's a curve, and make it look like it's symmetric about the axis of symmetry. Make sure it's symmetric, because if you draw a curve, I'm just going to go ahead and use this page. If you draw a curve, and it looks like this, and you draw the axis of symmetry, I'm gonna be very upset, because we talked about that doesn't look symmetric about the axis of symmetry. So do a good job with drawing the curve to make it look like it's symmetric about the axis of symmetry. Okay, so there are students that don't draw the curve to make it look symmetric about the axis of symmetry. All right, so make sure you do that. Okay, and that was it. So the vertex is -1, -2. Okay. The axis of symmetry. Let's talk about the axis of symmetry now. I want you to name it starting now. The axis of symmetry is x equal a number. So it's a vertical line, so it's x equal a number. And that number is whatever the x-coordinate of the vertex is. So that is x equal -1. If you notice, all these points here on the axis of symmetry, all the x-coordinates are -1. So it's just your x-coordinate. Okay? All right, let's look at number 4. Suppose in number 4, we had this. All right, number 4, suppose we had x minus 2 squared plus 1. Oops, let's suppose this is f of x. F of x equal x minus 2 squared plus 1. All right, so let's do a t-table. Remember, the first thing I want you to do is to find the x-coordinate of your vertex. So a parabola, all parabolas have a vertex. Find it. It's in this form to where you can easily locate it. Whenever it's in that form, locate it. So that's negative. So we find out what. So let's do this. Find the x-coordinate of the vertex. So all you do is see that part that's being squared, that binomial that's being squared, find out what makes this 0. So add 2 to both sides. So what makes that 0 is when x is 2. So I found the x-coordinate of the vertex. So this right here is going to be the vertex. I found the x-coordinate of the vertex. All I got to do now is find the y-coordinate. So we'll just substitute back in. So y equals, x is 2. So 2 minus 2 squared, and then plus 1. Now remember, that should be 0 because that's how we found it. 2 minus 2 is 0. 0 squared is 0. Plus 1. So that's 0 plus 1, which is 1. So the vertex is 2, 1. So I'll plot that. 2, 1. So that's here. Right here. And I found the axis of symmetry. So the axis of symmetry is going to go through this vertex. So let's go ahead and draw it now. Okay. So I found the axis of symmetry. So if I want to, I can label it now. If I want to, axis of symmetry. Right here. Axis of symmetry. The x equal. And this whatever. Notice all these x coordinates are 2's right here. So x equal 2. The vertex we found was 2, 1. And so notice this axis of symmetry. The number matches this number here. Okay, now all I got to do now is just pick 2 points on this side, use symmetry to get the other points. Okay, use symmetry. Okay, so let's see. So give me, use this to help you. Give me 2 numbers to this side. So just go 1 unit over. So when x is 3, when x is 4. 3 and 4. So I'm going to use 3 and 4. So when x is 3, I get y equals 3 minus 2 squared plus 1. 3 minus 2 is 1. 1 squared plus 1. 1 squared is 1. 1 plus 1 is 2. So I'll plot the point 3, 2. So 3, 2 is this right here. Okay. One more to draw. You need 2 on this side, 2 on this side to draw your curve. You have to have, once you find the vertex, you go 2 units. You pick 2 points to the right, and then 2 points to the left. So when x is 4, I get y equals. You plug in, wherever you see an x, you plug in 4. 4 minus 2 squared plus 1. 4 subtract 2 is 2. 2 squared plus 1. That's 4 plus 1, which is 5. So I get the point 4, 5. So 4, 5 is going to be this right here. All right? And then once you pick those 2, use symmetry to get the other points. So let's start with this one. This is 1 unit from the axis of symmetry. I go 1 unit this way. And I get that point. So think about reflecting by the axis of symmetry. When I reflect this point about the axis of symmetry, I get that point back. Here, that point is 2 units from the axis of symmetry. I go 2 units this way, and I get this point. Okay? And so then you just draw your curve. And there's your graph. Okay, so this is the graph. We said this was what? F of x equal x minus 2 squared plus 1. All right? All right, what about this one? Suppose we had number 5. Number 5, suppose we had this. All right, suppose we had f of x equal negative x plus 1 squared plus 2. Suppose I had that. Let's see, this was number 4. All right, so let's graph this. All right, so let's use the t-table. Remember, first thing I need for you to do is to find the vertex. Find the vertex. Remember, let's find the x-coordinate vertex. It's very easy to do when it's in this form. All right, now remember all these equations have this form. Okay? So let me go ahead and explain that. So when it's in that form, that's called standard form. Okay, so let me go ahead and tell you now. So if f of x equals some number times x minus h squared plus k. All right, so if it looks like this, if the variable's in parentheses and is being squared like this, and this is a constant, and a is some number, then this is called the standard form of a quadratic function. All right, standard form. Sometimes, I'm just letting you know, sometimes it's called the vertex form. Some books will call it vertex form. Right, and this reason it's called vertex form, but your book uses standard form, so it's called the standard form. So what I want you to do is notice this. When we went, and you got to see this, when we did number 2, let's say, number 2, recognize that this looks like this. You may say, well, there's no k. Well, k, remember, is understood to be 0, so that's plus 0. You see this? Plus 0. So I want you to notice that this right here looks like this. So whenever it looks like this, you can easily find the vertex. For right now, so I want you to do it. For right now, I'm trying to relate this back to last semester. So for right now, you just find out, well, what makes this 0? Okay? And then in the next lesson, you're going to see how to easily find the vertex from here. You don't have to use this idea right here. All right? Okay. So, so when you look at number 3, was number 3 like that? Let me find number 3. Where's number 3? So here's number 3. Did number 3 look like this? Look at it. It sure did. See it? A binomial squared minus or plus a number. Same thing here. A binomial squared plus a number. Okay? So we do number 5. We're looking at number 5 then. Right here, it looks like that. All right, so for right now, the way I want you to think about this, and the next lesson is going to change, that little part's going to change. For right now, I want you to, the way I want you to find the vertex, or think about finding the vertex, is it's in this form, the standard form. This is standard form. Find out what makes it 0. So x plus 1 is equal to 0 when x equals negative 1. All right, and so when x is negative 1, and I substitute negative 1 back into here, notice what's going to happen. Y equals, don't forget that negative out here, negative, then negative 1 plus 1 squared plus 2. Negative 1 plus 1 is 0. 0 squared plus 2. Now I want you to notice that all this is 0. 0 squared is 0. Negative 0 is still 0 plus 2, which is 2. So my vertex is negative 1, negative 2. So when I plot that point, 5, number 5 is f of x equal x plus 1 squared plus 2. So when I plot that point, the vertex, I get negative 1, 2. So there's your vertex. Okay? All right, I'm going to go ahead and draw the axis of symmetry. Draw the axis of symmetry right away. You can do that. It's no big deal. Just draw it. And that's going to help you with graphing some other points. All right, so there's my axis of symmetry. Make sure it's dotted, though. Use a dotted line. There's your vertex. Okay, and so I know the vertex, remember, is negative. Oops, did I mess this up? No. Negative 1, 2 is what we said, right? Yeah, negative 1, 2. All right, and then the axis of symmetry is x equal that number, which is negative 1. Okay, now pick 2 points to the right, and then use symmetry to get the other 2 points on the left. All right, so always go 1 unit. What I would do is go 1 unit, 1 unit. That's what I would do. So this is x equal negative 1. Go to 0, and then go to 1. That's the way I would do this. You could pick any number you want to. Just make sure whatever number you pick for x, that it stays in this grid. I'm hoping that it stays in this grid for those. So if x is 0, and we said 1. So let's do it 0 and 1. So if x is 0, I get y equals negative 0 plus 1 squared plus 2. And so I get negative 0 plus 1 is 1. 1 squared plus 2. Now be careful. 1 squared is 1, because 1 times 1, but that becomes a negative 1. Okay? Because remember right here, negative 1 plus 2, which is 1. So I get the point 0, 1. So I plot 0, 1, and I get this. Now use symmetry. This is 1 unit from the axis of symmetry. Go 1 unit this way. So I get that point on that side. Okay? Now, for when x is 1, I get y equals negative 1 plus 1 squared plus 2. So 1 plus 1 is 2. 2 squared, make this negative though, plus 2. 2 squared is 4, so that becomes negative 4. Make sure you see that. Don't say 4, negative 4. And negative 4 plus 2 is a negative 2. So I plot the point negative 1, 1, negative 2. So that's this. Use the idea of symmetry. 2 units this way, 2 units this way. All right, and then I connect them. Kind of like this. All right, make sure it's a curve. Don't make any of them go straight down like this. Don't do that. Don't do that. Don't do this. Okay, make it curve. So make it look symmetrical also, okay? Make it look symmetrical. And so there's your graph. Now notice this time it goes down. Do you see why it goes down? In the others, when we talked about this, in the others, this graph, let me get to the graphs. This graph here went up right here, because remember that was a positive 1. So since that was positive, it went up. Since this is positive, it went up. The number right here is a positive 1. Here, though, this is a negative 1. So that's a negative 1. Let me rewrite it. So that's a negative 1. So since it's negative, since this is less than 0, it opens down. All right, so always keep that in mind. All right, and let's do one more with this, with one of them going down, and number 6. Number 6, let's suppose we had g of x is equal to negative x minus 3 squared plus 4. Let me make that plus 4. So negative x minus 3 squared plus 4. So for right now, again, find the vertex. Find the vertex. Now in a little while, you in the next lesson, we're going to, from this, you can easily determine the vertex. You don't have to do what I'm telling you. But I want you right now. I want you to do this though with this, just because I'm trying to relate this back to a previous course. So find the x coordinate, the x of the x. Find the x coordinate of the axis of symmetry. I'm sorry, of the vertex. And so this right here, the binomial, all you look at is a binomial, x minus 3, and find out what makes that 0. Well, that's 0 when x is 3. So I found the x coordinate. I want you to think is this. What do you think, and this is going to be important for the next lesson, what do you think is going to be the y coordinate? Well, whenever we found this, I want you to notice, when we found this and I plugged in, here was negative 1, and I plugged in negative 1, didn't you realize that this right here was going to be 0? And all you're left with was this number 2, this constant. So when I did the other one, watch this. When I did the other one, right here, remember we saw that what makes this 0 is negative 2. So when I plugged in negative 2, didn't this go away and you're just left with 0? So when, let me find that other page just to kind of give you another example. Here, when I plugged in, see when we found the x coordinate to be 2, right here. When I plugged in 2, won't this always become 0? Because that's how we found 2. 2 minus 2 is 0. 0 squared is 0. And all you're left with is this number. So when, if I were to plug in 3, do you think that my y coordinate is going to be this number? Let's think about it. When x is 3, and I plug in 3 for x, I get y equals the opposite of 3 minus 3 squared plus 4. Well, that's 0 right here. So this whole thing is going to be 0, and 0 plus 4 is 4. So in the next lesson, we're going to use that. We're going to use the fact that if it's in this standard form, now this is true only in standard form, if it's standard form, you can easily find the vertex in standard form. All right, so plot the vertex, and then you're almost done. Once you plot the vertex, you are almost done. So 3, 4 is here. All right, remember we're graphing number 6, and number 6 is g of x equals negative x minus 3 squared plus 4. Now I want you to notice, see how this is negative right here? That number on the outside, negative 1? The graph should open down. Graph should open down. So we found the vertex. So the vertex is 3, 4. All right, and then we found the axis. We know the axis of symmetry. The axis of symmetry, remember, you got to say x equal. It's a line, so you got to name it using a line. So it's x equal, and notice when I draw the axis of symmetry, no matter what point I use, what's the x-coordinate always going to be? Well, it's always going to be 3. So that's your axis of symmetry. X equals 3. And all you do is pick 2 points to the right, use symmetry to get the other 2 points. So just go 1, 1. So if this is 3, then I would choose 4 and 5. So let's see what happens. So I'm going to do 4 and 5. 4 and 5. All right, so when x is 4, here's what I get. I get y equals negative 1 times 4 minus 3 squared. 4 minus 3 squared plus 4. Well, 4 minus 3 is 1, so I get negative, the opposite of 1 squared, like this, so that's 1, plus 4. 1 squared, remember, is just 1, 1 times 1, but that becomes negative 1 plus 4, which is 3. So I'll plot the point 4, 3. So 4, 3 is here. Use symmetry. Go 1 unit to the, see how this is 1 unit from the axis of symmetry? Go 1 unit this way. You found the other point. Okay, now let's do 5. When x is 5, I get y equals negative 1 times 5 minus 3 squared plus 4. 5 minus 3 is 2, so I get negative 1 times 2 squared plus 4. 2 squared is 4, so it becomes negative 4 plus 4, which is 0. So I get the point 5, 0, which happens to be the x-intercept. So 5, 0. And so to use symmetry, this point's 2 units from the axis of symmetry, so go 2 units this way. All right, so all parabolas have an axis, have symmetry. So think about reflecting this point about the axis of symmetry, you get that point. But think about distances. All these distances will be the same. 1 unit this way, 1 unit that way. 2 units this way, 2 units this way. If the next one were 3 units, then 3 units, and so on. All right, and so you just connect them kind of like this. Do the best you can. And then you're going to notice in the next lesson or the next one after that, that all quadratic functions have a y-intercept. They don't always have an x. I want you to notice that. We're going to talk about this. Did you notice that they didn't always have an x-intercept? See right here? Did this graph cross the x-axis at all? No, but all of them had a y-intercept. So all quadratic functions, in fact, all functions that are continuous will have a y-intercept. They may not have an x-intercept. So this one didn't. But in number 6, in the next lesson, you're going to have to, at that point, find the intercept, find the y-intercept. But here you did. All I want you to do here, all I want you to do in this lesson right here, is find the vertex, find the axis of symmetry, find 2 points to the left, 2 points to the right rather, and then use symmetry, find the other points. That's all I want you to do. All right, and then you're done. That's it. Okay, so in the next lesson, we'll go a little bit further with this. We'll do a little bit more things, but using what we did last semester, with a couple more things dealing with axis symmetry, you're set for the next lesson.